Oh, okay. So this is what it looks. So this is what it looks like now. Oh, there it is. Okay. I will be honest. This is the first time since YouTube changed their system and stuff like that of how live stuff is conducted. This is the first time I've ever actually used this material, so you'll forgive me if it seems a little awkward initially. Hello out there, folks. So it is Monday, March 16th, 2020. For those of you WWE fans, happy Austin 316 Day. Uh, and and like I said, this is my channel. This is Learn Math with Brian Sapinski. And as you saw me announce over the weekend, this is going to be the first in a series that is going to be very different from anything that you or I have ever done before and stuff like that. Basically, what this amounts to is, like I said, many kids around the country. Yeah, probably you have kids as well, or if kids out there, if you are watching, hello there. You're stuck. You are forced out of school because of the coronavirus issues. So, but you still have schoolwork to do. Distance learning is what a lot of us are in the middle of now, and so that's what I'm here for. I've got my whiteboard set up there, and everything is ready to go. So basically, this is your chance out there for at least the next hour to watch live, submit your questions. I'll be watching here in the chat. I'll see what things you want to know about, and whatever it is you wish to discuss, we will get some examples up here to try to help you through your material and stuff like that. So that's going to be the nature of what's going on. We're going to do this every day for at least the next 2 weeks, Monday through Friday, right here live at 2:00. Because at least that's at minimum, that's how long I'm going to. The school that I teach in Belleville, New Jersey, is going to be not working and stuff like that. Okay. See, now the idea is you're supposed to reply in the chat. You're not supposed to call my house. Okay, so that's the way that goes. So who knows there? But and oh, by coincidence here, hello. Oh, hello. Okay, all right, Joey. If you're gonna come down here, you got to bring your math work. Okay, let's go get your math work and let's demonstrate for the nice folks at home. Okay. Okay, and here, while we're waiting for some of you guys to chime in with your questions, whatever. Okay, Joey's going to bring his work down. Now, incidentally, I know you haven't seen me make any videos with the kids for a while. There will be some coming soon. Things between getting busy and they weren't doing stuff in their books in the chapter order that their material went through, and I like to go in chapter order. So we got delayed for a little while, but don't worry, you'll get there will be videos picking up with both of them soon. Okay, and here comes Brianna actually first or whatever. Hey, so bring it on in. Okay, I apologize. We don't have a way to sit down quite and stuff like that. Here, grab one of the giant comfy things, and we'll yes, just plop and keep in time and stuff like that. All right. Okay. All right. Oh, here. Let Brianna go first, and you chill on the sidelines. Okay. So
chill.
All right. Okay. All right. Joey, this is not mugged for the camera time. Okay. So yeah, you can tell folks this is going to either go very well, or we are going to have laughters and disasters abound for these next 2 weeks. So just stay tuned. Like I said, we are live, we are unscripted, and
we have no idea what we're doing.
Well, we know what we're doing. It's just how it's going to come out. We have no idea. So just bear with us here. Okay, what do you got here? Okay,
no one knows.
Okay, all right. Okay, but Joey.
Stop. Dad, I think I broke the zipper on my backpack.
Okay.
Mom, I broke the zipper on my backpack.
And we're off to a flying start already. Okay, but it's okay. She can
go
open. Okay, but all right, but where's the work?
Glue.
Get the work over there.
I can fix it with super glue.
Where's
God?
Where's the work in your bag? Okay.
Mom, there it is.
Okay, Brent, as you've seen before from the videos that we've done previously, she is in 5th grade. Okay, and yes, I know you have been very nervous about your divisions of fractions. Yes, so eventually we will make formal videos for all the fraction work, for all the operations, but let's deal with what you've got right now. Now, so let's see what you've got currently here. Okay, you mind opening to the page? I don't know where you are. You got to show me. Okay.
Yep.
You sit and chill. Shh.
Chill.
Okay.
I'm gonna chill. So like this is like we learned a trick.
Okay. Wait. Okay. Wait. Explain the problem first. Tell me exactly what it is that we're looking at here.
So like,
okay.
It's like a trick that can make it easier. Like I don't understand.
Well, first explain what it is.
Here, can I show you?
Okay.
Okay. So like, there's like this trick where like you have like a problem.
Well, okay, but what's the okay. Show the problem.
Like I'm just doing a random problem.
Yeah, that's fine. That's how I operate too.
7, something like this. So like the trick is you keep this,
right?
You change it, and then you flip it.
Okay,
but
right.
The point is, okay. I don't get how you can get
okay.
the same answer.
Okay, all right. Okay, I'll explain it to you in a second. Okay, but first, just to make sure. Okay, you understand what turning it over like this is called when you turn the numbers into fraction. What is the name for that? What is the name for that flip over? There's a word that's called. And those of you, any of you high schoolers out there are watching, you better know this word because it comes up quite frequently. What is it that you call it when you turn the fraction over? What is that turnover called?
I don't know.
Do you remember that? Okay, right.
Didn't learn it.
Okay, I'm sure you've heard it at some point. The name it's called the reciprocal. That's what it is that's called. Anytime you turn the numbers in a fraction over. Okay, now, you're asking the question of why is it?
42. So how do you get the same answer? It's like
okay.
The same, like if it's like different ways.
Okay, all right. Well, all right. Let's look at this.
Since they're different operations.
Are you gonna let me talk?
You get a different answer.
Are you gonna let me talk?
Yeah, it's the one
Close the marker, by the way, for a second. Okay, I just got these. I want to make sure these last the whole 2 weeks. Okay, so anyway, all right. Okay, and as I explain this, okay, any of you that want to chime in, whoever, with your own comments to back me up, feel free to mention this. Anyway, okay, so here, this is so weird. So here's the story. Joey, shh, come on. All right, so here's the deal. All right, under normal circumstances. All right, now, well, here, just to give an idea before I talk about this one, I want to first demonstrate a problem that has that I want to start with a basic division. Okay, I want to start with a whole number division. Okay, I'll come back to this one in a second. Okay, I just want to show a whole number division first, and show it with the reciprocal, and give you the basic idea. All right, so just take, for instance, just for example, let me use this as our example. Okay, 8 divided by 4. Now, anytime okay, but here's the thing. Listen to my question for a second. Anytime that you divide by a whole number, what do you expect the end result to be compared to what you started with?
Smaller.
Okay, you expect it to be smaller. Okay. Okay, like I said, yeah. Anytime you divide by a whole number, okay, the result is going to be a smaller result than what you started with. Okay, that much is going to be in place. Now, with a whole number like this, okay, you always want to recognize that any whole number can be turned into a fraction. Okay, and that fraction can be established by just placing the silent 1 underneath it, because 4 divided by 1 is.
And this is like
whole. Yep. Yeah. Okay. Yeah. Yes. Okay. We got that. Then. Just leave it there. Okay. Now, So when I turn this over by getting the reciprocal over, 4 over 1 is going to become 1 over 4. And now you have this multiplication. Now, again, I will pose the question here, right? Anytime that
still equals 2.
Okay, but here's, let me again stress my question. All right. A time that you multiply by a number that is, now I shouldn't specifically say less than 1, because I don't want to okay, or excuse me. All right.
Okay, JK. Okay, JK for you. What? I just.
Okay. A time you multiply by a fraction where the result is between 0 and 1. Okay. I want to stress that because we want to make sure understand that we're not going into negatives here at all, or any sort of thing like that. You know what I mean? So anytime you're multiplying by a fraction between 0 and 1, okay, again, what do you expect the result to come out to compared to the original?
When you divide?
No, I'm saying when you multiply by a fraction when you multiply by a fraction that is somewhere between 0 and 1, like this is 1/4.
Less.
Okay, again, you expect it to be smaller. So that's part of the reason. And again, yeah, when you multiply across here, 8 times 1, you get 8. 1 times 4, you get 4. And 8 divided by 4 gets you 2. So you notice how the reciprocal gives you the exact same answer. Yeah. Okay. So, oh, hey, and it looks like a couple of my guys are here. Hello out there, Darren, Ryan. Good to see you. Whoever, we'll be with you, and I'll get to your question in just a second. So that so we don't and Darren, don't worry about how you're watching it. It's okay. It's perfectly fine. I'm just glad you're here and that we could get everything checked out. Okay, so. But now you see how the reciprocal thing works. Now, the same kind of thing is going to be true within all of this. Okay, now let's reverse everything. Okay, let's suppose that this. Let's suppose that this is the division.
Wait, these are mine, so give it back to me.
Okay, all right. Done. Okay, well, don't worry. That's why I got some before. That's why I got some before I left school. So, because I know you were busy with those things. Okay, so here. All right, so let me switch the process then. Okay, so now here's the thing. Okay, so now what if instead let's put the division, let's switch where everything started by. So now we're dividing by a fraction. We're dividing by a fraction that is somewhere between 0 and 1, and we are multiplying by a number that is a whole. Okay, you're going to see now the results are going to change. So
if you divide like the
well, let's
whole
say if you multiply by a whole number, okay, that's greater than 1. What do you expect the answer to be compared to before?
Bigger.
It will be a larger answer. Okay, in this case, 8 times 4 would get you 32. Now again, the reciprocal, again, when we're divided by division, you're going to see that it also ends up being larger here. And if you think about what you did in your last section, remember what you did. This 8 that you're starting with indicates that you have 8 whole objects here. Okay, and whoop, I made one too many. Okay, so, and the idea is, if you're saying you're dividing by 1/4, that means that you're breaking these up into 4 equal pieces on each one and stuff like that. Okay, but the idea is that now, again, a whole number divided by a piece of 1 means you're counting up how many pieces that you've got and counting these all up. 1, 2, 3, 4, 5, 6, 7, 8, and all the way around. Are you watching? Okay, and so on there. There's the 32 that you're supposed to see. So that's why it checks out there. Okay, so you see how You see how it is that it's supposed to work. Look at it from the multiplication perspective, okay? Look at it from the multiplication perspective that after you use the reciprocal to turn it over and turn it back into multiplication, because as I told you before off the videos, division is multiplication just
like
in reverse, but it will when you turn it back to multiplication, you will see the effects that the number that the divisor is supposed to have on your initial starting value. So just apply it back to multiplication rules, where after you turn it over, if the number you're multiplying by is bigger than 1, expect a larger answer. If the number you're multiplying by is less than 1, assuming that it's still positive, it will produce a smaller number.
So that's the same thing with division.
That's what we were saying the whole time here.
Wait, Connie?
That's
so if you did something if you did something like this, it would
okay.
be,
6 times 1/5. Now
be
normally,
greater, but
okay.
If it was
No, wait, no.
Wait,
no.
I mean, black. Oh my God, it would be like it would be a whole number.
Okay, yeah, you're counting. Yeah, you're counting.
That
would be this will be small, because this is because this is saying that you're counting by 1/5. Yeah, you're counting by 1/5 until you get to 6, which means you're breaking up the 6 into 1/5 size pieces and seeing how many pieces do you have. That's gonna produce, when you turn it over, 6 times 5, or 30 pieces. Whereas this, it's saying you're taking what's already a fraction and you're dividing it further 6 ways. That's going to produce a smaller fraction, in this case 1/30.
Huh.
So that's the way that plays out.
Yeah,
okay,
that
so
sense.
that's the kind of thing you're looking for there.
Oh,
okay, so that's the kind of thing. All right. Okay, I'll tell you what. You go try here. You sit over there. Try over here. Try a few problems from your stuff or whatever, while I get to a couple of our viewers here that as I clear the board and get to the business there. Okay, so all right, we have a question in the chat room. This is from one of my students a couple of my students at where I work in Belleville High School. Again, hello, gentlemen. Good to see you there. And don't mind the craziness of my kids. What did I tell you? Okay. All right. This is not dance party here. All right.
I wasn't dancing.
You were pretty close.
Yeah, you were jumping up and down on the couch.
See, for those of you who wonder why the videos that we've done week to week have so many jumps in everything that's going on, this is why. Or I shouldn't say that totally. It's crazy.
Or he messes up what he's trying to say.
Yeah, but that's it's all with it. Okay, all right. Come sit over here so you can.
Goodbye.
Okay, come sit over here and Brianna.
Okay.
Brianna, come sit over here. All right, come on, because I got to get this moving on for the next guys here.
Give me.
Over here.
Give me my marker back. Take it.
Come on, you're holding up the show here. Let's go. Hi. Okay, all right. Your turn's coming in. No. Come on. No drawing now.
I wasn't.
Okay, just sit and wait your turn. Okay, your turn's coming. Okay, relax. Sit, relax, do your stuff. Okay, now. All right, so we got a question. We're switching to geometry mode now, folks. Okay, the question I'm being asked, and Ryan, Darren, if you're still there, or whatever, we'll get everything settled here so you can take a look at some things here. All right, the subject you are looking at here. Okay. For my geometry students, and perhaps yours out there in YouTube lands, focused on the subject of segment addition. Okay, now I'm going to admit there's been a number of us that have been honestly a little perplexed as to we were hoping that segment addition would be a simpler topic than it actually than it's given the impression of being. But listen, everybody gets things the way they get things. I'm not worried about However, when you get it, as long as you get it. So here, but here's the again, here's the basics. Let me first show the segment addition again in general general terms and stuff like that. Okay, again, the idea here is again, all right. You know by now, you know that the definition of a segment in general is that you have it's a portion of a line that has definitive endpoints. A line is supposed to go forever from from end to end through one dimensional through all of time and space. That okay, that much you already know to be true. Now, in the meantime, however, a segment is just a cutoff portion of that thing. Now, every time, as soon as you have a segment, it's always going to be measurable. You're going to have some type of amount that you can establish for whatever it is. So let's say that we call this segment AB, which you've seen this before. All right, that's the segment notation. You write that by name and stuff like that. Okay, you can write it as AB or BA. It doesn't matter which way you write it. But when you're going to write it as a measurement, all right, get down. Okay, come on, enough. Sit and wait your turn. All right. Okay. Now, when you go to list it as a measurement, okay, we don't put that over bar on. We list whatever it is. So let's suppose that in this segment, let's say that the AB as a whole was 20 units long. Okay, and it doesn't matter if it's 20 centimeters, 20 inches, doesn't matter whatever the case is. Okay, if you're following me so far, Ryan, and Darren, just please chime in with
Who's Ryan?
one of my students is watching. And he has a question. Not the Ryan you know. Stop. Okay, thank you. Yes, good. Glad you're here, Ryan. Okay, so let's suppose that the measurement of this segment is 20. Now you have to understand, Joey. Yo. Okay, so now let's suppose that you took this segment and you broke it off somewhere. Okay, let's say you broke it off at some particular point. Now the thing is, if I snap that segment, think of it like a piece of spaghetti. You break that piece of spaghetti, now you've got two pieces, and each one is smaller than what the original was, and things like that. So like let's say I break this apart at point C. Okay, let's say it's here. Now the idea is you now have these two smaller segments. You've got AC and you've got CB. The thing is, if you rejoin those two smaller pieces back at point C and you add those measurements up, they have to total what the measurement of the whole segment originally was right to begin with. So if you think about it, if we're saying that the whole thing is 20, okay, and then let's suppose that, and please, by all means, jump in and supply an answer as you could. All right, let's suppose that the AC portion was 13. So if you know that the one piece of the segment is 13, and we've had it established that the entire segment is 20 units, then if you know how much everything is, and you know how much a piece of everything is, how do you get the other piece? Okay, so you have to recognize what it is that you're doing. Yes, exactly. CB would be 7. It would, because think of it like a one-step algebra. So you've got the 13 here. You don't know what CB is, and you've got the 20 there. It's a one-step algebraic equation. That's exactly how it goes. So you minus the 13 over, and so you've got the CB equals 7, and that's the measure of that piece. Okay, that's the way that you want to look at each of these circumstances and stuff like that. Okay, now that's so, and now by the same token, now understand, depending on what information you're given about the two fragments, you always have to understand that it could be that you could be subtracting with these measurements. You could also be adding with them and stuff like that. Okay, yeah. It depends on whether you're given a piece and the whole, or whether you're given two pieces. So let's just suppose for a second, again, keeping this rule in mind. Okay. Let's suppose for a second.
Dad, can you keep this?
What?
Keep this
Put whatever you need to in there. It's fine.
Okay. Can I have my marker back?
Okay. All right. But this is okay. But this is not for. Okay. So by the same token, if instead of being given the whole and a piece, what if you're given just the pieces? What if you're told that the AC measures 12 and the CB measures 5? So in a circumstance like that, okay, if you then want the measure of AB, just again understand, as long as this is continuously moving in one direction, okay, you've got that this is 12, you got that is 5, and just put it together. That's all it amounts to. Okay, so in the end, then you get your measurement 12 plus 5 here. Jump in, Brianna. 12 plus 5 will give you how much?
12 plus 5 is 17.
So the measure of the entire segment AB is 17. That's all there is. That's all there is to that. Okay, now that's from a straight number perspective. You should be able to have the idea on that first. But now let's take things one step further, okay? Because obviously now the information.
Here, I'll break.
Now the information is going to
Joey, your turn is coming.
Your turn is coming. You gotta.
Your turn is coming soon.
All right.
Joe, go hide in the corner. Go with mommy.
She's trying to help this out, folks. Bear with us here. Okay,
Joey,
so
you gotta do your work with mommy.
I hope you guys are having fun with their shenanigans. Anywho, okay, so now let's take a look at this from an algebraic perspective. Stop. Okay, now what if? Let's go back to the original information that we had. Let's suppose that AB had a measurement of 20 again. Let's put that amount back. Thank you, Deja. Yes, I see you there. Okay. Yeah. Are you entertained yet? Okay. Now let's suppose that instead, let's take things one step further. Let's put a little bit of algebraic process into this and stuff like that. Either or, Ryan. You can send it to me either way. Your questions and whatever else. So let's suppose that we had some algebra involved in this. Let's suppose that the AC measurement. Okay, here we'll take it one level at a time. What if CB had a measurement of 3? Actually, okay, all right. I guess I gotta do this sort of a little better here. All right. What if CB had a measurement of x plus 3? And let's suppose that AC had a measurement of let's say 2x. I'm just trying to make sure I get this to work. 2x minus 1. Okay, now, from that perspective here, the same rules of the segment addition apply, and they will continuously apply at all times. Okay, so you want to recognize that, again, the full measurement is 20, and it becomes from the combined addition of these two amounts. So we know that AC is 2x minus 1. We know that the CB is x plus 3. Okay, so all of that is right in there. Just set up the addition sentence in the exact same fashion as you did with just the two regular numbers and stuff like that. Okay, now we proceed from here by simplifying the algebra, getting it down to like terms. As my students have heard me say many times, and any of you watching out there, I'll advise you of the same thing. When you're dealing with any basic level algebraic problem, you have to get each side of the equation down to no more than 2 terms before you can start trying to cancel things from one side of the equation to the other. So I've got 4 things here on the left side. I got to get that simplified down to 2 things by combining the like terms. So we combine first the 2x and the one single x here. Remember, in order for you to see that x, there has to be at least 1 there. Otherwise, you would not see it. So 2x and 1x is going to give me how many x's? How many total x's is that? 3 x's. Okay, so you got that. So you got the 3x. Now we combine the minus 1 and the plus 3. So basically 3 minus 1, who wins?
3.
No, okay, by how much? 3 minus 1 would give you by 2. So we finish with a positive 2 there, and we get the 20. Okay, now you got it down to a maximum 2 terms on each side. Now you perform your cancellations with the 2-step algebra as it shows there. So
I don't get it.
Well, remember, you're only in 5th grade. I'm just helping you. Yeah, now exactly, Ryan. Now it is just regular algebra, right? So you get rid of you cancel the +2 by doing a -2 to both sides. Cancel that out. So we got 3x equals the 18, and then we cancel the ×3 with a division of 3, so we get the x equals 6. So you have that result in play. Yes, okay, Deja, right on the ball there. Very good. Glad. Okay, now so you got that amount. Okay, now you just have to, now depending on the problem that you're working on, sometimes they just want you to find x and that's the ends of the road, no problems, no worries. There are going to be some times, however, where they want you to take it one step further and they want to actually know what the definitive measurements of the segments happens to be. Okay, so in this case, let's suppose that they wanted to know the measure of each of the fragments and the whole in whatever fashion the algebra is presented to you. So in this case, we'll plug in the 6. Okay, for the CB, that means that you are calculating 6 plus 3, which would give you a total measurement of, in this case, 9 for CB. Okay, that's there. Okay, and so, and then for the guys, keep it civil in there. I see you chatting. Don't think I don't. Okay, and then for here, the 2x, we plug in the 6. 2 times 6 minus 1. Okay, so the 2 times 6 gets you 12. 12 minus the 1, you get 11, and that's the measure of AC. And everything then pieces out to 20, like it's all nice and proper, like it's supposed to be, and you're good to go. All right. So that's how that kind of piece looks or whatever. Okay. So we've taken things to that level and stuff like that. And let's take it one little step further, because like over here, I still gave a definitive answer here for the one segment. Let's just see for a second what it looks like taking it one step further. If everything were algebraic right from the start. Okay, again, same rules apply. Okay, so what if? Okay, here I'm just going to redraw the segment here. Now I've got too much clustered together. Try to fancy pants it is going to
keep it nice.
Take a bit or whatever. Okay, so let's reestablish our segment here. All right, let's just say again. All right, so let's suppose we were told this information. Let's suppose that AC, and if the numbers I come up with here on the fly here are a little messy, just bear with me here, because I'm just trying to invent this as I go here. All right, let's suppose that this was 3x plus 2. Okay, let's see if the CB was x plus 5. Okay, okay, now give me 1 second. I'm just picking a value for x here because I want to get this to make sense with the thing I put at the other end, because what I'm also going to do is I'm going to establish an algebraic amount for the full segment AB, but I got to first know what value I'm making x here, so let me just see. Okay, all right, I got my number here. Okay, now I just got to get it to make sense over here. So, okay, there. Okay, and I promise this is going to work out to exact thing. So 5x minus 1 for the AB. All right, so once again, knowing that these are the pieces, AC and CB, knowing that those are the pieces, and this is the whole thing. Again, the two pieces have to add up to make the whole measurement. So we put everything in place. You've got the 3x plus 2. You got, plus you got the x plus 5. And on the other side, you got the 5x minus 1. Okay, so everything is where it belongs again, like I said. Sum of the pieces equals the whole thing. That's what you see there. Okay, so that's what's in place. Now, from here, once again, I got 2 terms on this side. That's okay. Here I've got 4 terms. Got to narrow that down. Got to simplify it. So once again, combine the like terms. You got 3 x's and 1 x for a total of how many x's? 3 x's and 1 x here. So count them up. How many x's?
4.
4 x's. Okay, got that. And then you've got positive 2 and positive 5. So that's positive 7.
I keep thinking the X's mean something.
Well, they do represent a number.
I mean,
We don't know what the number is yet, but that's why we have to get narrowed down to that point.
No, it's just the thing is like I don't. I don't know anymore.
Okay, when you do figure out what you were trying, what thought process you had, no, jump back in.
Fancy stuff, like I think it's not too normal. Yeah, no,
Again, there is normal. Okay, well, when you get to that point later on, probably in like 6th or 7th grade, I'll get
yeah,
you.
then I'll probably
it. I'll show you a little better the like term concept and stuff. Anyway, but all right, moving on forward here and stuff like that. Okay, so then we've got the so now both sides are at 2 terms. Now we start canceling things. Since you have 2 sets of like terms, that means that you have to send the ones with the variables to one side of the equation, the ones without variables to the other side of the equation. That's the way that's going to go. So usually I prefer to find which one of these has the smaller value among the x's and sends the smaller one over to the bigger one. So that means I'm going to send the 4x over to the 5x. We do that with a minus 4x over there. Gone away. And okay, in this particular example, we got a little better. We're kind of afforded a little blessing because 5x minus 4x is going to give us just the 1x. So the good news is we don't have to do any division at the ends of this problem because we're going to whatever answer we get on the other side, that's it. No division involved. We got a single x and we're all good to go. So now we have to get rid of the minus 1. We negate the minus 1 with a plus 1. We send that over to the other side so that both sides are down to 1 on 1. And we get our result of x equals 8, as you can see it there. So that's the way that's going to look. Now, once again, if the problem that you're answering only wants the value of x, then fine, great, you're done, all set in a neat, tidy package. But if they want you to go further and get the measurements of everything individually, then go ahead and do that as well. So let's see what everything comes out to. First, we'll plug the 8 into the 3x plus 2. So we got 3 times 8 plus the 2. We get 3 times 8, we get 24, plus the 2. So that gives us a measurement for AC of 26. Okay, so we got that. All right, so then we do the same thing over here with the x plus 5. We plug in the 8 plus the 5. We get that, and that gives us a total of 13 for CB, and at this point, you kind of have 2 choices as to how you want to approach getting AB. You could plug the 8 into the 5 minus 1 as well and get 5 times 8 is 40 minus 1, which means AB measures 39. You could get that, or you could get the same 39 from adding the 26 to the 13 and get it that way too as well. Regardless of which way you want to get that approach, that's what you want to see. Okay, so that's the basis of how the segment addition works. Again, just recognize what pieces they're giving you. Get your equation based on whatever points are in the picture. Get everything set up. Just recognize here's piece 1, here's piece 2, and together, added up, they make the whole thing. Okay, so that's the kind of thing you want to see there. All right, so all right, so here, those of you out there who are watching and getting your questions answered with regards to this topic, okay, if you've got some of that work in front of you, why don't you try that for a little bit? Okay, we'll come back to you in a second if you've got any further questions or whatever. Okay, all right, so Joey, where's your work now? Okay, so while you guys work on a couple of those that are doing those business or whatever. Okay, I'm just gonna switch gears back to first grade with my little guy Joey here. Yeah, Mr. I want to get on camera. So okay,
No, I only do it like Brianna.
Yes, he's very obnoxious.
Yeah.
Just like me.
I have my
He
own
gets it
channel.
from me.
Hey, no,
I have my own
Does
channel.
you're not obnoxious. You're just highly eager to. You're just highly eager to to get in on the act and stuff
Yeah,
like
he
that.
gets it from me.
I'm eager too.
Hey, can I help with the
Don't
first
worry,
page
I love
step
these
too?
guys, and it's all set and good. Okay, all right. So, okay, Joey.
I'm gonna help
All right.
with the first page step too.
So you've got okay,
Yay!
Joey. Let's set it.
Wait,
We're
wait.
just setting up main subtraction. Okay, your object that shows here is it wants you. Yeah, which one is supposed to be the first page? Oh, this is the first page.
Yeah, the side where the staple is flat.
Okay. All right. So that's well here. That's
addition
that's the
steps.
rules. And, okay, but that's okay. Let's. So all they want here is
put it on the
okay.
board?
All right. This is just a chance for.
Don't do it.
Okay. All right. This is just a chance for Joey to just do a little first grade blitzing and stuff like that. Okay.
I have my
So
own channel.
okay, just hold chill. We got one thing at a time. All right. All right. So go ahead. Set it up, Joe, and you fill in the blank. I'll set it up. You out here. I'll set it up. You knock it down. Okay. So we got 3 plus something equals 6. Go. What do you got? Okay. Right. Yes. 3 and 3 and 6. Okay. I'll go down the column here. Okay. 8 plus something for 9.
Duh. Oh, that's so hard.
No.
Joey.
Oh,
Okay.
now it
Yes.
is.
Okay. All right. Okay. We got a 3 plus 2. Okay. Don't mind how he's writing these numbers here, Joey. You gotta actually move over so they can see. 6 plus something for 8. Count your way from 6 to 8. No.
What? Oh, now I know. That equals 12.
Yes. Okay.
I forgot.
Count your way from 6 to 8. 7, 8. How many?
2.
2. Thank you. Yes. Keep calm and count on. Okay. From 7 to 9. Okay.
Same
got that.
thing.
Okay. From 5 to 7. No,
that's 2. That was 2. It's like the same thing.
Okay.
Like 3 times. It's the same thing
Okay.
over and over.
Well, that's just coincidence, not design. Okay. From counting 3 forward from 6, we get
I want to make one for him.
no. Okay, sure. All right.
Not a great one.
But I'm going straight from the page, so you chill. Okay.
That was
I
easy.
want to write them down.
Okay.
Is that a 5 or
5. That is a 5.
Not a great one for him.
No, stop. He's going to create in a minute.
5 plus
Starting at 5, count 3 steps forward. Okay, sure. And okay, here's a slightly bigger one that they gave you, but the same rules.
one of my favorites, 16, because I'm 6 years old.
Well, I know he really likes the number 6 because that's current age. Here, I got a silly question for you, Joe.
What?
6 is one of your favorite numbers right now because you're 6. What's going to happen when you turn 7 in August?
I will like 7.
You know, I mean,
Second.
6's treated you very well, I would think, right? So
Yeah, that I used to do that too. Or like my favorite.
your favorite number was your current age.
Yeah, but now my favorite number is 5. Like,
Okay.
and I'm sticking.
I've
with
always
5.
been a fan of 4 for whatever
I like
reason. I don't
5,
know why. 4,
I used to be a
4
fan of 3.
4. Yeah. 3 was always a big thing for you. And stuff like that.
Yeah.
Okay, all right.
When
All
I
right,
was
we'll
a
talk about that
kid.
more in a minute. Okay, all right, now,
I
Joe.
like the number
Okay, now. All right, so
5 'cause I
here's
was
the deal
born on
now. Okay, now.
January 5th.
The problems you have here at the bottom here, okay, it's asking you now to create your own problems. Okay, so it's giving me a +1, a +2, and a +3. So you fill in both of the blanks. Okay, you pick a number to go in front. Okay, all right. Okay, he's doing his doubles facts, which incidentally, the next time that Hey, Joey. One of my students, Deja, she likes the number 7 too. So
I like 7.
so
I like train.
so it's right there. Okay, Joey doing his doubles facts there, or whatever the case is. Which, incidentally, the next time I do a first grade video,
It'll be
we're gonna be working on adding doubles like that.
I'm
and
getting
things like that.
ready.
So
I'm getting ready.
yes, we'll be back.
Yeah,
I'll tell you now, folks. It's gonna be a little bit before you see a new video with them a little bit, or whatever, because I'm actually kind of between laptops at the moment, as you saw me say in the preview announcement for
his
these.
other laptop broke.
Yes, it tried to break apart on me and stuff like that. So
It broke like one of the nights.
yeah, it was it happened just about a week and a half ago. So I'm in the process of getting a new one. I will have the video software to go with it and things like that. So it just yeah. You too, Deja. Glad you could join us. If you have any more questions, you know where to find me. Just keep on working through things. So you guys take care of what you have to, and we'll move ourselves forward and stuff like that. And I'm glad the kids entertained you. Okay, so
Like
so
this
that's
video.
okay. Well, hang out. We still got a little bit more time and stuff like that.
Yeah,
Okay,
we
and
have
did you work on your stuff here? Go work on your questions so that if we have to fix something, we can hear live on the video and stuff like that. Okay. All right. Okay. Because we still got a little bit of time. I mean, now understand. So that you guys are aware of the timetable for these videos. Matter of fact, here, help him fill in this information, because now that he's done it, let's make sure he gets it on paper and stuff like that. Okay, so here, pencils over there. Okay,
Oh yeah, there's my pencil.
While we got a couple of my plan ultimately but he's supposed to write it.
Oh.
I'm saying help him write this information down. Okay, please stop, guys. Come on. All right, now you're getting a little too antsy here. Okay, now you're making it a little too antsy. Okay, can we, Joey? No, Joey, I need you over there and working on his stuff. Working on your stuff, filling in your answers. Okay. Okay. So anyway.
I'd like to see you.
Okay.
One more time.
All right. Let me.
Joey, nope.
Let me.
Why can't I sing?
Can't sing a song here, Joe.
No, not the time.
Not the time.
There may be a time, but this ain't it. Okay. Anyway, as I was trying to say a couple of minutes ago, the basic premise, for when we go to do these live streams with these distance learning things for these next couple of weeks, or however long we have to end up doing them, my plan is, as I said, that we're going to I plan to go for at least an hour. Yeah, every day here and stuff like that. If it happens that we have to, depending on who chimes in and who out there in the world has questions, that if we need to go a little bit beyond an hour, I will go up to 2 hours. It's no problems, no worries ever. But I guarantee you guys. Okay, what are you guys doing?
He's trying to be a cat.
Enough.
Joey, fill in what's on the board.
Write your stuff down now. This is why I said, guys, I said laughters and disasters. I'm fully prepared for anything. Anyway, but I promise you guys at least 60 minutes of content, or an attempt at 60 minutes of content, based on everything that's going on. So as we need to fill time, I've got a couple of other things that we're going to we'll fill in the blanks with and stuff like that, based on some other classes that I'm currently working on. But please, by all means, keep your questions coming. Even if it's something that we already did earlier in the video, if there's something you want to look at, please, again, just let me know. If you have any specific examples of the questions that you're looking at, throw them in the chat. We'll get them up on the board, so this way we can take a look at it.
I think it's backwards.
So now, it has to be. I'll tell you later. So anyway, so we got a few minutes still. Now I want to just show something else here, and this is something that some of my other students are currently working on. For those who do not know, aside from the traditional high school maths of algebra and geometry that we've done over the years and things like that. I also have some other classes I've taught over the years and things like that. One that I am currently teaching, which I enjoy a great deal, and especially to those of my students that are watching here in the underclassmen ranks. I hope that one day perhaps you will join us for this. However, I do a lot of work in what is called discrete math and statistics, which is pretty much it's a lot of off the beaten path kind of stuff or whatever. These are the kind of things that you get some applied maths in the world in different ways. They don't there are some formulas involved, but they're not like the straightforward kind of formulas that you normally would expect. And a lot of them are there's many of them that are simpler than you might think that they are. Like for instance, one of the first things that I was teaching my classes during this year, we started the year by talking about the methods of voting and stuff like that. Okay, let me just do this one example with them, and we'll let you jump back in. Okay, so when a voting process takes place, there are many different ways by which a vote can happen. Now, usually when you guys vote, you usually have a setup where you have a list of candidates. Like here, we got the presidential campaigns starting. Okay, it's gonna be Donald Trump versus whoever the Democratic nominee is, whatever the case is. The point is that when there's two people, you vote for the one that you want, and that's your person. But there are many votes that you will take that you will be involved with in your lifetime, where it's not just simply a this or that thing. It could be that you have to pick from several things, and even in some cases, you're not just strictly picking the one favorite that you want, but you have to take the candidate, but you have to take the candidates and you have to rank them. Okay,
so like this.
Kind of, sort of, but it's not like but it's not like that. I mean, that's not the way you would write it. I know what you're thinking. I know what you're thinking of when you speak of ranking. Yes, okay, all right, but it's not
Kahoot.
Yeah, okay.
It's like Kahoot ranking.
See, she knows Kahoot too. So okay.
Yeah, we use it in our classroom.
Yes, exactly.
Kahoot.
Okay, all right.
No,
Okay, but let me get
Smiley face. No, I loved him.
crazy. Anyway. Okay.
Good Lord.
Okay, can I do my example here so we can get back to your problem? Okay.
Sorry.
Okay, bring him upstairs, please. Okay, so let's suppose, okay, you have a set of four candidates that you have to pick from, and you have to give in preference what order you want those things to be chosen from. So let's say out of those four candidates, let's say that B is your first choice. Let's say that C is your second choice. Okay. A is your third choice and D is your fourth choice. Okay, so that's the way it is. Your third choice and D is your fourth choice. Okay, so that's the way it goes. That you are conducting. There are several ways by which to determine who is the winner of the election when you take not just your vote, but also everybody else's vote that is involved in the election. Because let's say that there are 20 people involved in. Let's say there are 20 people that cast their votes in this election. Okay, and obviously they're all going to have their different preferences. Okay, now in organizing those votes, you want to put them into a table and sort out like how many of each ballot selection that you've got. So let's suppose for a second, that if we set this up in the table here, okay, let's say you got that. So let's say as far as how many first place votes, how many second place votes, how many third, how many fourth. Okay, let's say when all the ballot tickets are counted, and we see what everything everything has. Let's suppose that the following. Again, we're going to say that there were. We're going to say that there were, aside from a black smudge, that there were 20 votes. So let's suppose that as far as first place votes go. Let's say that A got 6 of the first place votes. Let's say B got 4. Let's say C got 7 and D got the last 3. Now let's see in terms of second place votes.
Wait,
okay.
so each of these categories got 20.
Yeah, so we're seeing how the 20 votes are split by candidate and by order of thing. Yeah, so the columns have to count to 20, the rows have to count to 20, or whatever the case is. So that's the story there. All right, so anyway. So let's say that A got, in terms of second place votes, let's say they got 2, B got 5, C got 3, and D got 10. So that's that there. Okay. So then, all right, now let's see the third place votes. So let's say A got 9, which means 6, 2. So, okay, that means they got 3 fourth place votes. So I want to make sure the columns add 20 as well. Okay, let's say that B got 6. That means there's 15. That means 20. 5 to complete the 20 over there. Let's say here C only got 1 third place vote. That means they got 9 last place votes, because that completes that. Good Lord, what is happening up there? 16,
He's trying to unlock the door.
And then 4 and 3 there, and that completes the 20, and we're all set to go. Now, again, depending on. So I figured. So depending on. These are the kinds of circumstances where I expected the wheels to fall off the wagon with this thing. Hey guys. Anyway, so now, depending on the voting method that you're doing, there's several ways to determine exactly who's the winner of this election. The one I'm going to demonstrate here is the most mathematical by pure calculation. Well, there is going to be an addition involved, but not quite what you think. Wait. Let me explain. The method that we're going to look at here is what is known as, again, this is just one method of determining the winner of an election from these preference votes. It's what's called Borda count. What it essentially involves is that depending on where the vote falls, either first, second, third, or fourth, each rank of vote gets a score. Okay, so let's say, like for instance, let's say that every first place vote you get, that gets you 4 points. Let's say every second place vote gets you 3 points, then 2, then 1, and so on. And understand these scores can be whatever. Okay, usually it's just going to be in descending order, where the bottom gets 1 and every one above it gets a point after it, like that, and stuff like that. But it could literally be whatever. Like first place might be 10 points and second might be 7 or whatever. Okay, so but follow this first as a general premise. So if you want to get a candidate's score, you have to go through all their information and take the number of votes they got at that rank times what the score for that rank is. So if I want to do A's, that means I would be calculating 4 times 6. I would be calculating 3 times the 2 times the 9, and 1 times the 3. I do all those multiplications and I add them all up, and I get my grand total of scores here. All right, so let's see what we get here. Okay, so 6 points in second place votes, 18 there, and the 4 times 6.
24.
Okay, so we add those up. So let's see, we got 30, and 21. Okay, so a grand total of 51 points for candidate A. So that's how many points they got. And then you do the same with each of the other players' votes, and whoever's got the most in these Borda points, they are the winner of the election under this method. That's the way exactly how it works and stuff like that. So just to see how the rest of them go. So for B,
I lost it!
So you got that. You got that. So that's how where each one goes. Okay, so you got 4 times 4, 16, 15, 12, and 5. Grand total, you got 20 and 28. So B only got 48 points. So right now, A is still winning. Okay, we check C. 4 times the 7, 3 times the 3, 2 times the 1, 1 times the 9. So let's see. You get 28, you get 9, 2, and 9.
Oh no.
Okay,
You don't get
so we
99.
counted up. We've got 18, 20. Again, C got 48, so he's in a tie for second. Okay, and then we go with the with D's listings. We got 4 times his 3, 3 times his 10. A lot of points right there. But so even though he got the least number of first place votes, he's got a lot of seconds that'll make up the difference potentially. Okay, you might if he ends up winning, you might think that that's unfair, but that's the nature of how this method goes. Different voting methods have different strengths and different weaknesses. There is no one absolutely foolproof voting method in terms of getting a winner. So you have to understand that coming in. Every voting method that you know of has its own strengths and weaknesses. You want to find out about the other ones? Come join me in discrete math. So anyway, let's see the other ones. We got 12 here. 3 times 10, 30 points there. 4 times 2, 8 points, 3 points, grand total. And if you take a look, we got 20 here, 30 there's 50 plus the 3. D ended up with 53 points. So D is the winner of this selection. So whatever it was being voted for, D's going to walk away the winner under this particular, the board account method and things like
Return
that.
of Mr. Smiley.
So yeah, he gets the smiley and all that is fine and good.
He's like,
Okay,
whoa.
so
He's like,
that's the
like,
nature of
"Ooh."
it there. So and that's how it happens
You're
there.
getting
You
way
know,
you are
so
Smiley.
that's the basis of what happens there. Okay, all right.
Chaos on the whiteboard.
Yes, okay. I think we're having a little too much chaos here. All right, okay, all right. Okay.
Chaos
all
on
right.
the whiteboard. Okay, my turn.
Okay, all right. Okay, all right. Really quick. Okay, I got time for one more question here. Unless any of you out there have any other things you'd like to ask there. Okay.
Come on.
Okay. Order of operations here. Okay. All right. Okay. All right. Set it up.
Bye bye.
Stop.
Okay.
So, all right, real quick.
Okay. If we don't want to know about your tic-tac-toe.
We'll get a chance. I get a chance for that somewhere in the thing because I remember some of the problems you were working on the other day. They play good to Hollywood Squares, but we'll come back to that later. Okay, I'll show you later.
So this is like the problem that this is how they wrote it on the paper. And then they put in. Wilma. They put this in last answer. Y'all like Wilma?
Stop.
Don't abuse Wilma, God.
I didn't.
So I know this is 4, but does that mean I would bring down the?
Okay, all right, here, wait. Let's hear it.
So,
Let me wait. Can I clear the space first? Stop. Can I clear the space here for a second?
We don't throw Wilma at me again. Wilma.
All right.
Oh no, the markers.
So here, you got the 4 here, and that's fine. Okay, by the order of operations, by standard PIMA. Okay, you do that first. Now, I'll explain later why I say PIMA. Okay, I haven't had a chance to talk with you about that on the side. Okay, so everything else comes down. Now, at this immediate moment, there is a reason why I refer to it as PIMA. I will talk to you about it later.
Oh, I get it.
Okay, all right, okay. Now. Let's move on.
Parentheses,
can we get
exponents, multiplication, because multiplication is the same as division, and then addition, because addition is the same as subtraction, so
Yes.
Pima.
Yes. Some people refer to it even slightly differently from that. It is what it is. Okay, so but let's get back to the problem here, because take a look now. Take a look now at where we stand. You did the parentheses first. You did the 2 times 2 inside the parentheses. You got the 4. That's fine. Now, since you have completed all the operations in the parentheses, you will notice that I removed them from the problem. Now looking at what remains, okay, which calculation would you have to do next?
You'd have to do.
You'd have to do the division next. Okay, so we do this. So you do the 64 divided by 4. So real quick, okay, let's get that.
That's like.
Go.
Wait. No, wait, no, wait.
How many?
Wait.
How many 4s can you count out of 6? You can count 1.
2.
Right. Drop the 4.
6.
So 6. So little nice of the Okay. Are we in there somewhere? Okay, wait. Okay. I don't know if we checked out for half a second there. So, according to the order of operations, according to Pima, she did the 2 times 2 first. She got the 4. With all the calculations inside the parentheses done, we eliminated the parentheses. From there now, reading the rest of the problem, the division, we have a division and subtraction remaining. The division is next. 64 divided by 4, we get the 16. And then 3, we finish with 13. So there it is. So a little over order of operations amidst the chaos here to tie everything up in a nice and neat bow. Okay, and I think we better cut this off for today before things get even worse. Get up. Okay. And guys,
he's choking me.
Okay. Guys, stop. Enough. Okay. And with that, ladies and gentlemen, I think I better cut this off before this gets any crazier, because it's clear that work is over. At least in these guys' minds. So, all right. Enough. Go. Go. I'm gonna wrap this up.
Give me my markers back. And I have to say something before we go. What?
Nice and quietly say what you have to say, because we have to check out.
What?
What is this? You miswrote that.
Oh, it's a 2. Okay, here, wait. No, I get what you're trying to say. I'll write it for you.
They always have to have the last word, don't they?
Yeah.
All right. While they're saying
Wait.
while they're giving their final message, I will just tell you guys that again, I hope we helped you in the midst of all this mess going on with the distance learning and stuff like that. And like I said, we'll be doing this every day for the next 2 weeks. We'll talk about whatever it is that you like. So listen, if you know anybody anywhere across the country that needs help and could benefit, even if you just gotta double check one little thing, please, by all means, spread the word. We're gonna be here. I'm here to help you with whatever it is that you need. Okay, and if you like what we've been doing here, as always, please make sure to like, share, and to like this video, share it with people, subscribe to this channel to get more.
And make sure you get 1,000 likes. No, Joey, and that's too ambitious. Make sure you give this video.
So,
I know what that means.
But that's the story there, guys. So we'll be back here tomorrow, live at 2 p.m. for another rounds of this. For another rounds of the distance learning and stuff like that.
No.
Okay.
Check out my silly.
You guys will have your chance when everything is all said and done. Okay. We'll see what we can do. Okay. All right. Okay, guys. Now it's too much screaming. I gotta cut this off. All right. We'll see you guys tomorrow. Okay. Take care for now, and stay safe and healthy, everyone.
My channel's called Joey Stickman. Bye. Bye.